Hi everyone, in Algebra 3, here are your lesson 57 questions, the second half of the questions that you asked for. So for number 13, we have the central angle of a sector of a circle is 0.6 radian. Find the area of the sector. The radius is 4 meters. So for number 13, there's a formula for the area of a sector, and that is, for in radians, would be x over 2 pi times pi r squared. So for this one, the x is going to be the 0.6 radian over 2 pi times pi, and then the radius is 4 meters, so 4 meters squared. So what you need to do in this problem is you can notice that the pi's are going to cancel, and really you're just left with 0.6 times 16 and then divided by 2, and your answer would be 4.8 meters squared. And that's your result for number 13. And when it's not in radians, it would be x over 360 times pi r squared. Moving on to number 13 or 14, it says find the area of the segment bounded by an arc of measure 80 degrees and the chord which joins the endpoints of the arc in a circle of radius 10 centimeters. For this one, we have a different formula for number 14. It's the area of a segment. And that formula is the area of the sector, so x over 360 times pi r squared minus the area of the triangle, which is created within that sector. And that formula can be found by doing r times r sine of x, which is the height, divided by 2. So this is really just base times height divided by 2. Now they give us everything that we need. They give us that the segment is 80 degrees and that the radius is 10 centimeters. So we're going to start by plugging in what we have. So we have 80 over 360 times pi times 10 squared minus 10 times 10 sine of 80 divided by 2. Now that 2 can go into the 10 5 times. So when I plug this into my calculator, I do want to multiply this out fully. So it'd be 80 times pi times 100 divided by 360. So that'd be 69.813 minus, and then I'm going to do 5 times 10 times 80 sine equals, that would be 49.24. So I'm going to make that negative and then subtract that from the 69.813 that I had before. And that will give us an area of 20.57 centimeters squared, because remember it's an area, so it would be centimeters squared. And that would be your result. Now moving on, it says sketch the graph of the equation y is equal to negative x plus 1 and y is equal to x minus 2 squared minus 3. Shade the region that satisfies a system of inequalities. Okay, so for the first one, I know that that's going to be a line. And this line is going to be crossing at 1, and the slope is going to be negative 1, down 1, over 1. So it's a negative slope, and because there's an equal sign, it is going to be a solid line. So I'm going to draw my first line. The second line is going to have an axis of symmetry at positive 2, because remember, x minus 2, we would set it equal to 0. So that would give us an axis of symmetry at positive 2. And then it says down 3, so 1, 2, 3. Now, if you remember from your chart for graphing a parabola, it would be from that point over 1, up 1, over 1, up 1, or over 2 up 1, 2, 3, 4, or over 2 up 1, 2, 3, 4. So your parabola would look like this. Okay, and that's also going to be a solid line because of that equal sign. So when it says y is less than, that means I'm going to do everything underneath the line. I'm going to shade everything underneath the line. So I'm shading everything underneath my slanted line. Then it says y is greater than the parabola. So that means it's going to be everything above the parabola. And above would just mean everything above that vertex. So your answer is going to be the portion that's covered by both. And in this question, the answer is going to be what's inside the parabola but underneath your line. So inside the parabola but underneath the line. Okay, number 17. The first thing that we're going to do on number 17 is we are going to divide this equation by 2. So that would be cosine theta is equal to 1/2. So number 17. Now I need to determine in which quadrants is cosine going to be positive. So I have all students take calculus. I know that everything's positive in quadrant 1, and then in quadrant 4 that cosine is positive. So I'm going to draw 2 triangles here. Cosine is the ratio of adjacent over hypotenuse. So my adjacent would be here, my hypotenuse would be here. And I'm trying to solve for these 2 angles. Now those 2 angles are going to be 60 degrees because this is a 30, 60, 90 triangle. So my answer for quadrant 1 is going to be 60 degrees. But for quadrant 4, I have to subtract it from 360, so that would be 300 degrees. Now we know this is not going to be a 45-degree triangle, remember, because my hypotenuse would have to be square root of 2, not just regular 2. Okay, now moving on to number 18. Number 18 is actually basically the same problem, so we don't have to do a lot of additional work. So the only thing that's different is that we have a 3 that's attached to my theta. So that means for number 18, since I've already solved for the degrees, I'm just going to set 3 theta equal to triangle 1, and then 3 theta equal to triangle 2. But remember that for this problem, we're actually going to have 3 answers for each quadrant. So for quadrant 1, my first answer is going to be 20 degrees. My first answer for quadrant 4 is going to be 100. But to find my other 2 answers, I'm going to set 3 theta equal to 360. When I divide by 3, I get that theta is equal to 120. And this is going to be the difference between all of my answers. So 120 plus 20 would give me 140. 140 plus 120 would give me 260. And those would be my 3 answers for quadrant number 1. Now for quadrant number 4, I have 100 plus 120 would be 220. And then 220 plus 120 would be 340. Notice that all of those answers are going to fall between my parameters of 0 to 360. And I end up with 6 answers. So number 18 really just builded on what the results of number 17, so that you don't have to do extra work. Now moving on to number 19. So for number 19, we have cotangent of theta is equal to 0. Now I don't have any reference triangles that's going to give me a ratio of 0. So what I am doing here is I'm actually using my unit circle. So what I need to go through is I need to go through and draw my unit circle. So for number 19, I can always put, so that should be 3 theta is equal to 0. My unit circle looks like this. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cotangent is the inverse of tangent. So cotangent would be the ratio of x over y. So if I look at 0 degrees, that would be 1 divided by 0. Well, you can't divide by 0, so that's not going to be one of my answers. The next one, I have 0 divided by 1. I can't have that, so that can be one of my answers. So I'm going to set 3 theta equal to my first answer, which is 90. Then I have negative 1 divided by 0, can't have that. And then I have 0 divided by negative 1. Well, 0 divided by negative 1 is actually going to be 0 too. So I have 3 theta is equal to 270 as well. So I have 2 places that satisfy that cotangent is equal to 0. So my first answer is going to be that theta is equal to 30. And my second answer is going to be theta is equal to 90. But now I have to find my other 2 answers that would work for this equation. So you're going to set 3 theta equal to 360 just like you did on the last problem. Remember that this doesn't give you one of your answers. This is just going to give you the difference between this, your first answer, your next answer, and then your following answer. So 120 plus 30 would be 150. 150 plus 120 would be 270. Now those are your first 3 answers. Now your second 3 answers, 90 plus 120 would be 210. And then 210 plus 120 would be 330. And altogether you have 6 different answers. Now moving on, number 22, it says use the midpoint formula method to write the equation of the line which is the perpendicular bisector of the line segment whose endpoints are -4, -6, and 4, 8. Write the equation in double intercept form. So number 22, we actually have to follow the 4 steps, or this one will become 5 steps because we have to change it into double intercept form. I'm going to start by finding the midpoint between the 2 given points. So x would be equal to -4 plus 4 divided by 2, which would give us 0. And then y would be y1 plus y2 divided by 2, which gives us 1. So my coordinate is going to be 0, 1 for my midpoint. Step 2 is to find the original slope. So that would be y1, -6, minus y2 over x1 minus x2. So it'd be -14 for -8. Answer would be 7 over 4. But then for step 3, remember it's the perpendicular bisector, so we need to find the perpendicular of this slope, which would be -4 over 7. So now I'm going to plug this into the formula for step number 4. Y equals mx plus b, so -4 over 7 x plus b. I'm solving for plus b using this point right here. Now my x is going to be 0 and my y is going to be 1. So now I have 1 equals -4 over 7 times 0 plus b. So which means that b is equal to 1. Now I have my equation as y equals -4 over 7 x plus 1. But I need this to be in double intercept form. So the first thing I'm going to do is I'm going to move the x to the other side. So that would be 4x over 7 plus y equals 1. Now, for double intercept form to work, it would be x over a plus y over b equals 1. I already have the right side to be equal to 1, but I need to get rid of this 4 that's attached to the x. Now I'm going to do that by moving it down to the denominator by multiplying by its reciprocal, which would be 1/4. So your answer would become x over 7 over 4 plus y over 1 equals 1. And that would be your result. So that becomes a 5-step problem because we have to convert that from double intercept form instead of leaving it into slope intercept form. Now moving on, we're going to look at number 23. So for number 23, I have arctangent of tangent of 7 pi over 6. So the first thing that I'm going to do is I'm actually going to draw my snowflake to solve for 7 pi over 6. So I have 1, then 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. This would be 0. So if it's positive 7, that means I'm going to start counting in quadrant 1. So that would be 1, 2, 3, 4, 5, 6, 7. It's actually going to be in quadrant 3. And because the denominator is 6, well, that's a 30-degree triangle. So that means that this is going to be negative root 3, negative 1, and 2. So the tangent is going to be opposite over adjacent, which would be 1 over root 3. So I actually have arctangent of 1 over the square root of 3. So I need to identify where's the first place where tangent is going to be positive. And that first quadrant is going to be in quadrant 1. So if I draw my triangle again, opposite as 1, adjacent as root 3, hypotenuse as 2, I know this is a 30-degree angle. And 30-degree angles are going to have a denominator of 6 in radians. So there's two ways to determine this. Well, I know that this is in quadrant 1, so this would be right here. And that would be on the snowflake, it would be 1 pi over 6. So my answer would be pi over 6. But let's say you left it in degrees and you then needed to convert this into radians. So if this is 30 degrees, to convert from degrees into radians, it's pi radians is equal to 180 degrees. And when you simplify that, it would then give you pi over 6 radians. So either way, you can change your answer back into radians. So if it starts in radians, it wants you to end in radians as well. Moving on to number 24. So for number 24, I have cotangent cubed of pi over 4 plus tangent squared of 8 pi over 3. So I'm going to start by making my snowflakes. For the first one, that's actually going to just be in quadrant 1 because, again, if the number attached to the pi is just a 1 or a negative 1, that means it ends up either being in quadrant 1 or in quadrant 4. So this one's a positive 1, so we're going to, and we always start counting in quadrant 1. So this would be quadrant 1, and this would be a 45-degree triangle, so 1, 1, root 2. But then, and cotangent is the inverse of tangent, so that would be adjacent over opposite. Now for this 8 pi over 3, I'm going to draw my snowflake over here. So this would be 1, 2, and 3, then 1, 2, and 3. Starting at 0, I would count in the positive direction, which would mean starting in quadrant 1. So 1, 2, 3, 4, 5, 6, 7, 8. That puts me in quadrant 2. Because the denominator is 3, that's a 60-degree triangle. So this would be negative 1, root 3, and 2, and tangent is opposite over adjacent. Now for adjacent over opposite, that would be 1 over 1, and I would have to cube that, plus tangent is opposite over adjacent, which would be negative root 3, and I would have to square that. So 1 cubed is just 1, root 3 squared is going to be 3, so my result is going to be 4. And now moving on to your last question, which was number 26 on this lesson. So for number 26 on this lesson, the first thing that I recognize is that there's a number outside my logarithm, which is going to become the exponent of the 16. So this would become log 1/2 of 16 to the power of 3 over 4 minus log 1/2 of x minus 1 equals 2. Now 16 to the power of 3/4 can be done in your calculator, so it's 16 to the power of 0.75, which is going to be 8. So this right here would be 8. There's a minus sign between my logarithms. That means I take these two values and I divide them. So this would become log 1/2 of 8 divided by x minus 1 equals 2. Now to get rid of the log 1/2, I'm going to raise both sides to the power of 1/2. So this would be 1/2 to the log 1/2 and then 1/2 to the 2. This would cancel and I would be left with 8 over x minus 1 is equal to 1/2 squared, which is 1/4. So now when you cross multiply this, you're going to get x minus 1 is equal to 32. So your answer is going to be x is equal to 33. And then for part B, similar to part A, I have a number outside my logarithm, so that's going to become the exponent. So for number part B, I have ln of 25 to the power of 1/2 plus ln of x minus 2 equals ln of 2x plus 3. Now 25 to the 1/2 is just the square root of 25, which would give us 5. But because of this plus sign, we're going to take these two numbers here and multiply them. So that would be ln of 5 times x minus 2 equals ln of 2x plus 3. Now to get rid of the ln, we're going to raise it to its base, and its base is going to be e because it's natural log. So it'd be e to the ln, and then you cancel the ln's. When I distribute the 5, I get 5x minus 10 is equal to 2x plus 3. I'm going to move the 10 to the other side, so add 10. Move the 2x to the other side, which would give me 3x is equal to 13. And therefore an answer of x is equal to 13 over 3. And that concludes your questions on problem set 57 part 2. You do need to watch both videos in order for you to get all of your questions answered. I hope you guys all have a great day. Bye.